position plus change in position is position at time 3. Okay? I suppose you could say it's a rearranged form of fundamental theorem. If you integrate v from 0 to 3, what's the antiderivative? X at 3 minus x at 0. And so if I just move this over there, wouldn't that be x at 3? Yes? Okay. Today's lesson, I used to just, in my slide little, holy cow, how many times can we do velocity and movement kind of thing? Part 500. I used to not teach this, and it was bad, because as much as I thought, well, they'll figure it out, they didn't figure it out. It was disastrous. Okay, so we will go through this, and hopefully I will save you some pain, and I guess I'll do my job, instruct you. So here goes. When we don't care about direction, then we're dealing with speed, and I heard displacement also. Don't you agree that speed and displacement go hand in hand? We integrate speed to get displacement. Distance is what I meant to say.
Yes.
Okay. When we integrate speed, we get distance. We remove the sign, and I just want to know, how far you went? I don't care which direction, just how far did you go? But if I do care about direction, then I'm dealing with velocity. And integrating velocity, or making many different rate times time calculations, and adding all those distances gives you displacement. Now, in some of these problems on tonight's homework, they're going to try and bait you, get you to fall into a trap here. So the typical trap problem looks like this. The position function is given by this thing. And they'll ask you, trying to lay their trap, to find position at time 0, which is 1. And position at time 3, you go ahead and do that. I'll do that, and we'll compare answers in a wee minute. You get something like 23.5 or 47.5. Do you agree? Okay. Now, you know at time 0, the position is 1. At time 3, the position is 47.5 or 23.5. So question B, find the distance the car traveled from time 0 to time 3. People in a rush say, well, it went from 1 to 23.5, so the distance traveled is 22.5. Yes? No, that's the displacement. That's the difference in position. Displacement. Now, if I were sure that it's going forward the whole time, could I say, yeah, that's the distance too? Yeah, but I don't know that because I don't really know what the sign of the velocity is, so I really need to get into this. So, don't fall into the trap and just take change in the two positions because that's displacement, you're finding that distance. Instead, say you wanted to define this with a calculator. What would you do? You would say distance is integration of absolute value of velocity, right? I suppose you need velocity. What is velocity? 3t squared minus 3t plus, or minus plus 3t. That's what I said. Plus 3t minus 6. We?
Yeah.
Okay. And with your calculator, that's no sweat, assuming you know where absolute value is in your calculator. You good? Okay. Let's try this without a calculator. Without a calculator, we need to figure out what does the absolute value do. Now this, strangely, he actually has you integrate absolute value later, so you haven't done this yet, but it's pretty intuitive. If you were to factor this out, then the velocity graph would be a parabola opening up with zeros at negative 2 and 1. And without absolute value, it would want to look like that, right? But with absolute value, it would get flippity-flipped. All right. So because it got flipped, then this part is a different function than this part here, which did not get flipped. So because of that, I really can't just integrate one integral. What do I have to do? 2. So I will say something like the distance is the opposite of velocity from, remember it's time 0 to 3. So from time 0 to 1, I'm going to take the opposite of velocity. And from time 1 to 3, I'm going to take the straight up normal velocity. Okay, I don't need to put the function in. Let's minimize the writing. What's the antiderivative of velocity? Position. So I need to find the opposite of position change from 0 to 1 plus the same as position change from 1 to 3. Or I guess you could say negative x at 1 plus x initial plus x at 3 minus x at 1. I guess you could combine like terms. Should I just start putting stuff in, or should you want me to combine like terms? At any rate, we have a lot of those things. I know x initial from part A. What is it? 1. And I know x3, x at 3 from part A. It was 47 halves, I believe. Yes? You do need x at 1. The position at 1 is 1 plus 3 halves minus 6 plus 1, or 3 halves minus 4, or 3 halves minus 8 halves, or negative 5 halves. So this is the opposite of negative 5 halves, so that's 5 halves. This is the opposite of negative 5 halves, so that's plus 5 halves. So, lots of halves. How many halves do I have? 59 halves. Therefore, the distance was... You follow? Okay, so you have to consider the back and forth movement. Don't just take change of position, which obviously is displacement. In order to try, but not waste your time, would you do number 3 on the homework? Number 3 on the homework is right there for you. Might as well point out the homework.
The time equals 0 to 3.
Yes. Okay. Ready? What'd you get? Oh, sorry. Good point. Oh, so, for part A, x at 0 is 2, and x at 3 is 2. So the distance is 0, right? No, you goose. Let's find distance correctly. Distance is 0 to 3 of absolute values. To analyze when it moves backward and forward and how. So velocity is 2t minus 3. So the absolute value of velocity then would involve a graph that crossed the x-axis, or touches the x-axis rather, at 3/2, and got flipped up before that and stayed positive after, right? Do you agree? Like that? Okay, so this is equivalent to, this absolute value integral is equivalent to two integrals of the opposite of velocity from 0 to 3/2 and the same as velocity from 3/2 to 3. Really? You get the idea. So did you get 5.5? Did you get 5.5? Did you get 4.5? Did you, what the, are you alive? What the heck is going on out there with you people? Angie, talk to me.
Wait, I messed up, but.
Oh, what happened?
Wait, did you get 9 hours?
Yeah.
I got 9
I
hours.
would. Quentin already did this problem. Yeah, what?
You already did this.
Lindsay? Oracle?
I think they even said
Yes?
this is all been
What? Kylie?
This is.
What? I thought that, no, this is not easy. Never mind, I need to go slower. I'm sorry. First, do you agree that we need to analyze how it's moving backward and forward?
Yes.
Okay. Do you agree that velocity is 0 at 3/2? Yes. Do you agree that the absolute value of that means that instead of a normal line of a y-intercept at -3 and a slope of 2, it's flipping
I'm so mad.
up before 3/2?
Yeah, I get it.
So because of that, this first equation without absolute value would actually be the opposite of v on 0 to 3/2. And this part was not flipped, so it's normal v on 3/2 to 3. So I integrate two different things, really. And, shoot, I could have just done this by area. I didn't even think about that, but so be it. Can anybody do area? I thought about that. I didn't think about that. That would have been a good way to go. So, here we go. If that's my integral translation, then I integrate v, which is position, right? And position. Fundamental theorem of calculus. This would be opposite of x at 3/2 plus x at 0 plus x at 3 minus x at 3/2. Plus, in terms of substituting, I know this is 2 and this is 2. I need x at 3/2. X at 3/2 is 9/4 minus 9/2 plus 2. Common denominator is 4. I get 9 minus 18 plus 8. That is -1/4.
Wait, to get 9. Yeah.
So, if I plug -1/4, then I get 1/4 plus 2 plus 2 plus 1/4 is 4.5. Right?
Yeah.
Okay. All right. Well, I got to tell you, you're not inspiring me with confidence because that was the easy one of the two. This one is harder. In the last class, I said, go through it and work on it together and get it. But this class, I'm tempted to say, just quit. You can't do it. Well, you let me down. You're my golden children. What happened?
The weekend
The
happened.
weekend failed you?
Absolutely.
More juniors in that class?
The release point, 2 meters above the grade.
Yes. All right, do it. Succeed. Demonstrate your brilliance. Redeem yourself. You failed me once, don't fail me again.
Didn't fail you. So dramatic.
No, C1. So what I agree is I need to wait, yeah, I did.
You get it?
I just made
What's your
Wait, that makes sense, right?
Oh, it's absolute value of
Y times 0, oh, times 0.
the type of average value.
You just said, oh my god, yeah.
With X is here.
Always check your answer for reasonableness. In this case, an average height must be between 0 and 0.
Velocity of X is 20 meters per second. It's 20 meters. Oh, no, no, it means it's iteration of 1 second. So I can make the change height from 0 to 1.
But then it crosses 2 times. Oh, you can measure what's so you're supposed to integrate. So then you can just. Oh, I see. You can't just do that.
Yeah, right. They were enemy. Because of the
Yes?
I just don't know how to show my work for this.
Pretty sure.
I don't know which one
No, this is all. You have to set.
No, I got this.
4130.
Oh, so no calculator?
Why would you use a
I
calculator?
have no idea because I don't know what I'm
Are you
doing.
ready? Did you go 4130?
Wait, no, should the average be higher than 0.5?
It should be higher than 1.
Or higher than 1, yeah.
Yes. Obviously, the halfway point between 0 and 2 would be 1 meter, but it spends, because it goes slower at the top end, it'll spend more time at the, above that 1 meter. So I would imagine the average height would be above 1. Shall we start talking or no?
Yes.
Okay? I mean, something you know.
It's in the air for 1 second.
It's in the air for 1 second. That's important. How do you know that?
Because it's going horizontally 20 meters per second, and we like 20 meters. So
Yeah.
it's only been going for 1 second.
Yeah, the horizontal velocity is 20 meters in 1 second. Well, it goes 20 meters, so it must be in the air for 1 second. That one was easy to overthink. So, time in the air is 1 second. Now, later on, in Calc 2, you do a lot of projectile motion and parametric equations. So, now let's talk vertical. Average height. I could do the average value of the height function, but I don't have the height function. So, in a calculus way, not a physicsy memorized equation-y way, how do I get height? Integrate. Acceleration is negative 3.8, so velocity is the antiderivative. Negative 3.8 t plus an initial condition.
Which is.
It's
Why is it 0? I thought it was going 20 meters per second.
horizontally.
Okay, and a velocity in a vertical sense, at time 0, the velocity vertically is 0. I give it no vertical velocity component. I'm not giving it anything. All vertical movement is only due to gravity. So negative 3.8 t, the initial constant, is 0. Now I go to height. How do I get height? Integrate velocity, antiderivative of negative 3.8 t plus dt rather is negative 1.9 t squared plus some new constant. Do I have an initial height condition?
Yeah.
At time 0, the height is 0, so that implies that the height equation is negative 1.9 t squared plus 2. Okay, now how do I find the average height? How do you find average value of something you know? 1 over. I'll call that h bar for average height. 1 over 1 minus 0 from 0 to 1 of negative 1.9 t squared plus 2. So, why pick up a calculator to do something I could easily do mentally quicker? Negative 1.9 over 3t cubed plus 2t from 0 to 1. So that's negative 1.9 over 3 plus 2 minus 0. Maybe negative 19 thirtieths plus 60 thirtieths, or run in for the touchdown. Meters per second, meters per second per second. Meters, that's a.
Does that mean t equals 0, height would be 2?
I didn't get that.
Like in the middle column of your work?
I got C.
Yes, that time equals 0, height is 2. That's 0. Yes, you're correct. Wait, are you with me? Okay, that is that. You need to find out how long it's in the ground or in the air before you can integrate over the time frame. All right. Here we go. Here's your test. I would like you to correct your test in class. If you can, that would be great. Get it by the end of the class, but if you need more time, you might have to come in some other 7th hour or before class. I mean, these in the old books. You might be done with this page, you might not, but I have no idea who's done and who's not, so I'm going to give you both. If that's satisfactory.
Sorry?
Have you heard?
Tell me where it is.
It's on the board.
Oh, he put it back.
No, it's always there. It never took it off.
He definitely took it off.
You know?
It's like multiplied by 10.
Is that like that?
Oh, we have to get rid of the decimals.
All right.
Oh, it's high. You got me so excited. I was like, whoa, not bad. Oh, here. I'm in this 5. It's a 1. You are correct. Oh, perfect. Okay.
Okay, on the blue, all you can correct is the back.
Oh,
All the ones should be correct.
I'm stupid.
You should use one of these as your senior quote. That'd be so funny.
I think the best one.
Collapse.
It is after this.
Ooh, that was loud.
That was loud.
Is it 89 today? Going.
88.
okay, you were in good catch.
Sorry.
You're not really expert.
Okay. So, I'm going to pause this.